All right, welcome you guys. Let's go ahead and get you an A on your last chapter test. Okay, so looking at this first ellipse, we can tell that the center is going to be 0, 0 because it's just an x squared and a y squared. It's not like, for example, let me see if I can find one, something like this where it's an x plus 2 squared and a y minus 2 squared. If you just see an x and a y and no number after it, then we know it's 0, 0. Now, a squared for an ellipse is always going to be the bigger number. So that's 49. So if we square root, we find that a is 7. Now, because this 49 was underneath y, that means that we're going to go 7 in the y direction. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, and I'll be right there. And I'm also going to go down 1, 2, 3, 4, 5, 6, 7, and be right there. Okay. Now we're going to do the same thing, but with b squared. So b squared is 36. If we square root both sides, then we have that b is 6. And since that 36 was underneath x, then we know that we're going to be going 6 in the x direction. So 6 to the left, and then 6 to the right, and we'll go ahead and draw our ellipse. Now we can get our vertices from the picture. So just remember that the vertices are along the major axis. So the vertices in this picture are going to be this one and this one because this is the longer axis, okay? So our vertices are going to lie at 0, 7 and 0, -7. Now, something I do want to point out because it's going to be important as we move on is that another way to get your vertices is to take your center and then figure out if you're going to be adding to the x value or the y value. Since the vertices are up and down in the y direction, then we would be taking the y value and adding and subtracting a to it. Remember, a is for the vertices, b is for the minor axis endpoints or the co-vertices, and c is for the foci. So if we went in here and we added and subtracted our a, which is 7, then we would get 0 plus 7, so 7, and 0 minus 7, so -7, which is another way to get the same exact answer. This is going to be important on problems where we're not centered at 0, 0, or where we don't have a graph. All right, let's try it again. So the only difference between this one and the last one is that it's not in standard form. We don't have the equals 1 here. And they also wanted us to find the foci. So that's different too. So the first thing we got to do is we got to get a 1 on the right-hand side. So we're going to divide by 225. That's how we're going to go in and get that 1. All right, so 25 goes into 225 9 times. Oops, writing the 9 in the wrong spot. And then 9 goes into 225 25 times. Just use your calculator to get that for you. And so there is our standard form for our ellipse. So again, our center is at 0, 0. So I'm going to mark that on my graph. I'm going to write it here. And we know that a squared is the bigger number. So a squared is going to be 25. So if we square root both sides, we end up with a being 5. All right, and then b squared would be the smaller number, the 9. So if we square root both sides, then we get that b equals 3. So we have to look. The a squared, this one was under y, and this one was under x. So we're going to go 5 in the y direction. So up 5, put a dot, down 5, put a dot. And we're going to go 3 in the x direction. So 3 to the right and 3 to the left. And we will draw our ellipse. Now for the vertices, we can see them in the picture. Again, the major axis is vertical. And so these 2 dots are going to be our vertices. So if we wanted to record them, they'd be at 0, 5 for the top one up here. And then 0, -5 for the one down here. Now, another way we said you could go and get those is you could just say, well, I know I'm going to be adding to the y value because it's bigger up and down. So I would take that 0 and add and subtract a to it. We already found a to be 5, so we can plug the 5 in. And that's how you get what 0 plus 5 is 5, and 0 minus 5 is -5. So that's another way to get those 2 points. Now the foci, same thing. The foci also lie somewhere in the picture. I'm just going to put them in a fake spot, but they lie somewhere along the major axes. So that means that we're going to be adding and subtracting c to the y value because we're going up and down. Okay. So we just have to figure out what the c is. So remember, it's a squared minus b squared equals c squared. And we already know the a squared and the b squared, so we might as well plug those in. So 25 minus 9, which is 16. And we'll just square root to find that c equals 4. All right, so then over here, we're going to do 0 plus or minus 4. So that's going to give us 0 plus 4 is 4, and 0 minus 4 is -4. So our foci, our vertices, let me see. I think I might have been pretty close in the picture. If I were to go 4 spaces, let me just kind of erase. I'd be right here. Yeah, I was really close. And then down 4 spaces would be right there. So this looked pretty good. All right, let's try number 3. So same thing. We don't have it in standard form. So we're going to get an equals 1 by dividing by 324 to everybody. Okay. And 4 goes into 324 81 times. And 81 goes into 324 4 times. So there's our standard form for our ellipse. So a squared is the bigger number. So a squared is going to be the 81, which means b squared must be the 4. If we go in here and we square root everybody, then we have a equals 9 and b equals 2. So what this means is, let's say that, my ellipse, well, it is centered at 0, 0. Okay, so here's the center. Well, the 9, the 81 was underneath x, right? So I would go 9 to the right, and I would go 9 to the left. And that's where I would put my vertices. Let's pop a little bit. Let me move this a little bit, you guys. There we go, looks better. And then the 4 was underneath y. And so I'm going to do this 2 that you see in the y direction. So 2 up, put a dot, 2 down, put a dot. And that's going to be my ellipse, right? Oops. Now, so we want to know how long the major and minor axis are, right? Let's start off with the major axis. So the major axis goes this way. Well, if I went 9 this way and I went 9 this way, then 2 times 9 means it's going to be 18 long. If I do my minor axis, which is up and down, well, remember I went 2 this way and 2 that way. So for my minor axis, I would just do 2 times 2, which would get me 4. So there's our answer. You basically just have to double the A and the B. So this could be really quick if you've practiced a few and you understand, oh, okay, just get the A and the B and double it. All right. Number 4, find the vertices of the ellipse. Well, in order to find the vertices, we need the center. And that should take you guys no time at all. It's like my favorite question because we just changed the signs on these. So instead of a +2 for the x, it's going to be a -2. Instead of the -2, it's going to be a +2. Now, we can see that we're going to be bigger in the x direction because the bigger number is under x. Well, if we're bigger in the X direction, so something like this, then to get to my vertices, right, I'd have to add and subtract to the X value of the center. So our vertices are going to lie at -2 plus or minus a, comma 2. So we're doing it to the X because we're bigger in the X. So we got to hunt down a, you guys. Well, we know a squared is the bigger number. So a squared must be the 36. So if we square root, we're going to get that a equals 6. So let's go ahead and plug that 6 in. I'll probably do 2 cases just so everybody can really be clear on this. The first case is going to be -2 plus 6, comma 2. And the second case is going to be -2 minus 6, comma 2. So that's going to give us 4, comma 2 and -8, comma 2 for our vertices. No need to graph it. We could if we wanted to, but this will get the job done. All right, number 5. Almost the same thing. So we have to find the center. So change the signs on those. So -4 and +1 is where the center is. This time the bigger number is under Y, right? So that means it's bigger in the Y direction. So we'll have an ellipse that goes up and down, right? So our foci lie on the major axis, so the foci will go up and down. So that's why all the action is going to happen to the Y value. So to get to our foci, it's going to be -4, comma 1 plus or minus C. So we just have to figure out what C is. So we have a squared minus b squared equals c squared, our foci formula. Now we know that a squared is the bigger. So 25 is going to go here. And b squared is the smaller. So 16 is going to go here. 25 minus 16 is 9. And then we're just going to square root both sides to get that c equals 3. So let's go plugging that c in. So we got -4, 1 plus or minus 3. So -4, 1 plus 3. -4, 1 minus 3. All right, so 1 plus 3, that's just going to be 4. And then that's a 1, you guys. It looks like a parentheses, huh? All right, and then for this one, it's going to be -4, 1 minus 3. So -2. All right, I probably should pull out the answer key and make sure we're doing okay here. So the first one, 0, -7, 0, 7, good job. 4 for the foci and 5, yep, that looks good. 18 and 4, we look good. The one that we're on right now, -4, -2, and -4, 4. -4, -2, and -4, 4. Doing good, 100% so far. All right. Identify the vertices and the foci. I'd like to put an over 1 here, just so that way it looks like all the other problems. But we're going to go in and get the center first. So we're going to change the sign on the 6. So it'll be a +6. There's nothing with the Y, so that means 0. Now we can see that we are bigger in the X, right? Or sorry, bigger in the Y direction. Because the bigger number's under Y. So we're going this way. So that means to get to the vertices, right? I'm going to have to go and use the Y value of the center. All right, so for the vertices, we are going to do 0 plus or minus whatever we find A to be. For the foci, same thing. The foci also lie on the major axis. So we are going to be doing it to the Y value, but it's not A. Test yourself, see if you remember what letter it is. Hopefully you said C. All right, so let's go in and get the A and the C. So off to the side here, we know A squared is the bigger number, so the 25, and that the B squared is the smaller number, so 1. We are going to square root all of these so that A equals 5 and b equals 1. Now, the only other thing we need is c, so let's bust out that a squared minus b squared equals c squared. So 25 minus 1, that gets us 24. We're going to go ahead and square root, right? So we get that c equals. Now think of 24 as 4 times 6. And that's how you can quickly get that it's 2 root 6. So we're going to substitute in all those values, right? Right there. And then right here. So here we go. So we got 0 plus or minus 5. All right. Well, 0 plus 5 is 5. And 0 minus 5 is negative 5. So there's our vertices. Now for our foci, we're going to take that 2 root 6 and plug it in. So our two cases there are going to be 0 plus 2 root 6. That's just 2 root 6. And then 0 minus 2 root 6. That's going to be negative 2 root 6. Let's go check ourselves, make sure we look good on our answer key. 6, 5, 6, negative 5, 6, 2 root 6, and 6, 2, negative 2 root 6. Looking good. Write the equation of the ellipse in standard form. Identify the vertices and the foci. All right, so it's the same exact question, but they just didn't give it to us in standard form. So we're going to have to try to make it look like, you know, x minus h squared over something, and then y minus k squared over something equals 1. This is the goal that we want. I don't know if we're bigger in the x or in the y direction, so I can't really put the a squared or the b squared yet, because those might be flip-flopped. But that's what we're working towards. All right, so I'm going to go ahead and group together the x's, but there's only one. Then I'm going to group together the y's. And I'm going to move the 24 over to the other side. Okay, so what we want to do now is we want to complete the square. So we have to take half of b and square it. So we have to take half of the 14. So half of 14 is 7, and 7 times 7 is 49. So we are going to add 49 to this side, or whatever you do to one side, you have to do to the other side. All right, now there was a 1 in front. That's why, you know, when we multiply, we get a 49. And so that's why we just did the same exact thing to the other side. Okay, so then let's go ahead and factor, or write this in factored form. So remember, you can just simply use the number before you square it. So this should factor as y plus 7 squared. But if you're not sure, you can always say, okay, what are the factors of 49 that add up to 14? There's your 7 and 7. Okay. All right. So then over here on the right-hand side, we got to figure out what negative 24 plus 49 is. And I think that's 25, you guys. Okay, let's get the equals 1. So we're going to divide everything by 25. So we got x squared. Oops, why am I writing the equal sign? Plus y plus 7 squared over 25 equals 1. So this is the answer to the first part where it says write the equation of the ellipse in standard form. Now, if I want to go in and get the vertices and the foci, we need the center. So 0, because there's nothing with the x, and change the sign on that positive 7 and make it a negative 7. Now, a squared is the 25, the bigger number. And b squared is the the 1. I'm gonna erase that, so. Because I know it won't look like that one on the answer choices. All right, so then we're gonna square root everybody. And so we have that A equals 5, B equals 1. The last thing that we've got to get is the C. So A squared minus B squared equals C squared. So A squared is 25, so we'll plug it in. B squared is 1, so let's plug it in. Wait, that looks familiar, huh? And then just square root both sides. Wow, we just did this, you guys. So what was it, 2 root 6? Okay, so we've got everything we need now. So here we go. Now, the bigger numbers under y. So that means all the action is going to be happening to the y value. So it's going to be -7 plus or minus a. And then for the foci, it's going to be -7 plus or minus c. All right, so let's go ahead and plug in the a and the c, you guys. -7 plus 5. And then -7 minus 5. So -7 plus 5, that's -2. And then -7 minus 5, that's -12. So here's the answer to the vertices. And then the easier one, because we don't actually have to do the math, plus or minus 2 root 6. We stop there because it's not like I can add 2 root 6 to a -7. They aren't like terms. So that's as far as we can go with that. So check and see how we did, you guys, just to make sure I didn't make some little error along the way. That looks familiar. Okay, then we have, how come I don't recognize, maybe it was 0, -12 and 0, -2. Let me go back. It was, okay, so 0, -12 and 0, -2. And then let's go check these out. Yeah, -7 minus 2 root 6 and -7 plus 2 root 6. That's exactly what we have right here. Doing good. All right, number 8. Write the standard form of the equation of an equation of the ellipse subject to the given conditions. So I always like to draw a picture. You guys know me. So -10, 0, and I'm just going to try to make that out. +10, 0 are where our vertices lie. That tells me a lot. That tells me that my ellipse is going to be bigger in the x direction. Okay. And it also tells me one of my letters. Remember that the distance from the center out to a vertex is the letter A. So I now know that A equals 10. Okay. Then our foci lie at, let's say this is 6, and let's say this is -6. That's where our foci lie. Well, that they just gave me the letter C. So C equals 6. Furthermore, I know exactly which formula I'm going to be using. Both of them have the x minus h squared and y minus k squared equals 1. But remember, if you're bigger in the x direction, then the a squared has to go underneath the x. So we know this is the formula that we're going to be using. All right, our center, we know, is going to be 0, 0 from a picture. Okay, which means that there will be no h and there will be no k, or there'll be 0 in other words. So we're just going to have an x squared and a y squared. All right, now we know a equals 10. So that means that a squared equals 100, 10 times 10. So we can go ahead and put 100 into our problem. But notice at this point, we're missing the b squared. No problem. We can just use our a squared minus b squared equals c squared. we can plug in our a squared. Now we never did square c, but if c is 6, then c squared must be 36. All right, so I'm going to go ahead and subtract 100 from both sides. So we've got negative b squared equals negative 64. And then I'm just going to divide by a negative. And so what that leaves us with is that b squared equals positive 64. And all we need is b squared, you guys. So let's go ahead and plug them in right here. And we have the equation for the ellipse. Let's go check it out, make sure it looks good. 164. Oh, it's perfect. Very, really good so far. Number 9, same type of problem. So let's see here. You can kind of see the center right here. That negative 3, 1 is going to be our center. Because if I were to put that together, that'd be negative 3 plus or minus root 65, comma 1. So you can just tell that the negative 3 and the 1 is going to be where the center is. But I think there would have been other ways to tell too. Let me come in here and graph these points. So 6, comma 1, 1, 2, 3, 4, 5, 6, up 1. And then negative 12, so 5, 6, 7, 8, 9, 10, 11, 12. All right. We could have been able to find the center by, like we said in class, taking these two x values. So I'm assuming I don't know this negative 3 right now, you guys, right? Well, I could say, okay, negative 12 plus 6 divided by 2. That's how you find the middle of something. You add them up and divide by 2. That'd be negative 6 divided by 2, negative 3. So I would know my center would have to be at negative 3. It'd have to be 1 high. That's kind of obvious because the other two are 1 high, right? So for it to be smack dab in the middle, it has to be like level with the other ones, right? Okay. So hopefully you're good with that. Okay. All right. So let's see what we know, you guys. I'm trying to put this together. We know that the distance from the center out to a vertex is the letter A. And how far negative 3 is from 6? Well, it's 3 spaces plus 6 more. So it's 9 spaces. By the way, let me draw the pretend ellipse here, right? Okay. So we know A is 9, or A squared is 81. We also know the center, huh? So our center is at negative 3, comma 1. Okay. And then the foci, I'm pointing out that negative 3 plus or minus root 65, comma 1. Well, they're giving us the C right there. Because you know how it's always going to be, for the foci, it's always plus or minus C. So they're giving us the C. The C has to be the square root of 65. Well, these C's are confusing. Let me write center here so you guys know. All right. Okay. And we'll probably need to square that. So let's go ahead and square it. So C squared is 65. Okay. So the formula that we're going to be using well, the bigger number is going to have to go under X. So A is going to have to go underneath X. If it had been bigger up and down, then we would have put it under the Y. Now we know the center is negative 3, 1. When we plug it in, remember to change the sign. So it's going to be positive 3, negative 1. A squared, we already got, it's 81. But the thing again that we're missing is the B squared. So once again, we're gonna bust out A squared minus B squared equals C squared. We got 81 here. And we got 65 here. So I'm gonna go ahead and subtract 81 from both sides. Oh my goodness, okay, 81 minus 65. 16, that's a good number. Because then when we go in here to divide by a negative, we get B squared equals positive 16. And that's all we need is B squared. So we are done. Let's go check it real fast. So 81, x plus 3 squared with an 81, y minus 1 with a 16. We are doing good. All right, let's try number 10. So we got to switch gears now because now we're looking at hyperbolas. All right, so they're pretty similar, right? Like we know the center is going to be 0, 0. But the thing that's different is a squared isn't the biggest number. A squared is always the first number. So this 49 is going to be our a squared. And then our b squared is going to be 64. So that feels different, right? Letting the smaller number be a squared. But it's all about who's first. We also know this space is this way in the x direction because x is first. It has nothing to do with the bigger number when it's hyperbolas. It has to do with who's first. X is first, it opens in the x direction. 49 is first, so that's my a squared. All right, so then we're going to go ahead and square root everybody so that we get a equals 7 and b equals 8. So we're going to do everything the same as we would with an ellipse. We know that since this was underneath x, that we're going to go 7 in the x direction. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. And then this one was under y. So I'm going to go 8 in the y direction. And here's where it differs. I am going to draw a box here, right? So I'm going to go ahead and, well, I've got every color in the book here, huh? Let me draw it in red. There we go. And I'm going to do the same thing here. Oops, sorry. Left-hander issues. There we go. And then we'll make that red. Let me just change the color right here. Put a box here. Okay, so then we got to draw the diagonals of the box. That's going to be, help us guide our graph. There we go. And since we know that we open up in the x direction, aka horizontally, I know to draw my hyperbola here and here. All right, so graph the hyperbola, done. Identify the center. I guess we never wrote it down, but we knew it was 0, 0. And then for the vertices, same deal, right? Because it opens in the x direction, we're going to add and subtract the x or the a to the x value of the center. So a was 7. So we got 0, oops, plus or minus 7, comma 0. And so 0 plus 7 is 7, and 0 minus 7 is negative 7. And we could have gotten them from the picture also, right? It's pretty clear that this one, oops, is at negative 7, 0 right there. And that this one right here is at positive 7, 0. All right, let's go see what that looks like on the answer key. Negative 7, 0, 7, 0 looks good. And they won't have the box. I told you guys that anything that's dotted might not show up in the graph. But we are opening in the x direction, and we do go through 7 and negative 7. So this looks really good.